grocery. Okay. Question 2 in your assignment. The marketing manager for Capital Credit Union is considering developing an advertising campaign directed at female credit card customers. However, before continuing, she wants to know the difference in average credit card balances between male and female. She asked the database manager to select a random sample of 300 customers. These data provided in the Excel descriptive or do it by Excel to show the results. Okay. You can do it by hand or show the results. So in order to do it by hand, there are some calculations that we need to do. So we'll start with male, the first group. If you open Excel and you want to do everything for male, you add up all the different numbers under male, and they add to, I did an Excel, and they add to 173 191. You also do it for the sum of x squared, and it's let me just highlight this, 14932 7015. Okay, I can find the average for male. It's the sum over n, so 173191. And in the database there are 232 male. So 173191 over 232. This will give you average of 746 5193. And if you do the standard deviation, we need to do the total variations first. So this number is 149327015. The sum is this, you square, and there are 232. 149327015, 173191 squared over 232. This is the number 20037699396. Now, to do variance, we take this number and we divide it by n minus 1. So we take this number and we divide it by 231. So it gives you 867432639. And to take the standard deviation, we square root the variance, so we square root this number. So 2495221. So that would be the standard deviation for the first group and the average. So for male, I'll write it down here so that I remember the average is 7465129 with a standard deviation 2945221. Then we do the same thing for female as group 2. The sum for females is 52913, and the sum squared is 470 12517. To do the average, we need the sum, that's 52913. And the female group, there are 68 of them. So 52913 over 68 gives you average of 7781324. And to do the standard deviation, we have to follow the 3 steps. Sum of x squared, that's 4701217. Sum of x, that's the 52913. You square this, sample 68. 4701217. 52913. You square this over 68. This number is 5839199,809. So 5839199,809 over 68 minus 1 gives you 87152,23595, and then you square root it. So you square root this number, gives you standard deviation 2952156. For female, average is 7781324, and standard deviation 2952156. So we did the calculations. Now you need to construct 95% of the confidence interval to estimate the difference between me credit card of the two companies, males and females. If you're doing confidence interval, this is again 2 sample but independent. So 2 sample independent, and we're going to assume equal variances. Since they didn't mention anything in the question, so it's safe to assume equal variances. So the formula would be average group 1, average group 2, T star, SP, 1 over N1, 1 over N2. Now, for T star, we need degree of freedom. So N1 plus N2 minus 2. So as we know, it's 232 plus 68 minus 2. And that's 298. And alpha over 2, since it's confidence interval, alpha here is 5%. 0.025. You go to your t-table. The t-table I'm using doesn't have degree freedom 298. I don't know if yours does. I doubt it. So I'm gonna use the closest plus. So I'm gonna use 100 closest. You always, if you can't find the degree of freedom, use the closest one but less. So in this case would be 100. If you find in your t-table that either you have this one exactly or you have, say, degree freedom for 250 or something closer than 100, closer to this but less, use that. It's not gonna make a big difference. So the one I'm gonna use has a degree of freedom, a T number of 1.984. So T star 1984. Double check. Yeah. Now you also need to do the SP, and we know the formula. It's the standard deviation 1, standard deviation 2, n1 plus n2 minus 2. The first standard deviation is 294,5221. You square this, and 232 minus 1. Plus, you stay in the same line, of course. Standard deviation 2 is 295,2156. You square, and the sample is 68 minus 1 over the first sample plus the second sample minus 2. So we do the standard deviation, or SP, SP in this case would be 2946782. So we put everything together. Average group 1, average group 2, plus or minus T star SP 1 over group 1, 1 over group 2. So just doing the before plus minus, I get 316195. Now I'll do the after the plus minus. So the difference between mu1 and mu2 is between the two numbers. You minus them, you add them. The minus takes you down to negative 112,2412, and when you add them, it takes you up to 49,0022. Good? Now, they want you in B to interpret the interval, does there appear to be something to indicate difference between them? So first you need to interpret what the interval is, and B, so you say in 95% of confidence intervals based on 232 males and 68 females, and whatever the question was about, the credit card balances, the credit card balances is the difference, the true mean difference in credit card balances between males and females is between, and you put the two numbers, -112, 2412, and 490022, and if you're 95 with 5% chance of error. Good? Okay. Once you do this, how can you explain, does this show that they're different or not different? Now, when you do confidence interval for difference, whether it's two independent means, two dependent means, two proportions, any time you do confidence interval difference between two, you can end up with two negative numbers, two positive numbers, or negative positive like you have here. If you end up with two negative, negative, positive, positive, that means they're different. Since 0 is not within confidence interval. So, since you're negative, negative, you don't go through the 0, and if you're between two positive numbers, you don't go through the 0, then they must be different. 0 is not within. But if you end up with negative, positive, that means they're not different, since 0 is within. So the way you answer this, you say, since 0 is within confidence interval, the two groups are not different. So since 0 is within them, then they're not different. Good. Question 3. In order to estimate the effect of store-wide sales campaign on non-sale items, the research director of National Supermarket Chain took a sample of 13 pairs of stores, the mass according to average weekly sale volume. One store of each, the experimental group, was exposed to sale campaign. The other member control group was not. Everything is given in the Excel. If you open the Excel, you'll see that you have store and then list all 13 stores. You have with campaign and you have the without campaign. And you have the numbers for all of them. So if you don't do this using Excel, so you actually have to do this part. You just copy down or you can print it from Excel. And remember, these are sales items, the average weekly sales. So these are the average weekly sales. So store number 1 with the campaign give you 67.2 average weekly. Without the campaign give you 65.3. Store number 2 59.4 and without give you 54.7. I'm not gonna write them all down, but you need to. You're gonna add a column called D and a column called D squared. D would be the difference between them. So if you take this minus this, so this would be considered group 1, this is group 2. So you take the difference between them, this minus this 1.9. And this minus this 4.7. Third one would be 1 minus. So some of them could be different depending which number is higher. You do the difference for all of them. Here, you square the difference. So when you square this, it would be 361, 2209, 144. Once you do this, for all 13 of them, you need to find the sum of this column and the sum of this column. Make sure that when you add the numbers, leave this the negative number as negative, so it would be this plus this minus this plus this, whatever. So you add the D, they add to 47.5, and this column, when you add it, it will add to 295.3. Why we're doing this? Because this here is a dependent system. Two sample depend. Why is not independent like the previous two questions? Well, the accounting and the research, there were two separate departments that's independent. Males and females, two separate groups, independent. Here, you have one group. You have 13 stores, the same 13 weekly average sales with campaign and the same 13 without. So it's one group performing two tests. That's a dependent system, and that's what we do when you have a dependent system. So you go back to the question. All I need from Excel is basically just these two numbers. At 5%, can the research director conclude that there is evidence that the sales has increased for the non-sales items? So, sales campaign. Does the sales campaign, which is group number 1, increased? Okay, so you go H0, HA, or H1. Remember, group 1 was with the campaign, group 2 without the campaign. So, they tell you, has it increased? So, the campaign is more than before. If you bring this over, 0. And since we know it's a dependent system, for a dependent system, instead of this minus this, we say mu d, mu of difference. Here would be the complete opposite. You bring it over, it would be less than or equal 0, or mu d less than or equal 0. In English, true mean of weekly sales has not increased with the campaign, and this one has increased, but you have to write it in full. Now, for a dependent system, the test we use for hypothesis testing is d bar minus mu d sd square root of n. You see it in your formula. You might see nd or a small d in the bottom of the n, doesn't matter. Decision rule. According to your hypothesis, you have one tail, right tail. So, one tail right, if your t-test more, we reject H0. How do you get this number? We need degree of freedom, n minus 1, that's 13 minus 1, 12. And we need alpha, it's 5%. We don't need to divide it by 2 because it's one tail system. So you go to your t-table, 5% with the degree freedom 12. You'll see the number 1782. So this number 1.782. Let me just double check. So please double check, make sure that I didn't do anything wrong in getting this number from the table or anything. So degree freedom is 12, 1, and 5%, 1782. Okay. So analysis. Or also called calculations, we need to do everything. We start with d bar. That's the average of differences. So you take the sum of differences, you divide by 2, by whatever the sample is. So 47.5 divide 13, and this will give you 6,538. So I did d bar. Mu d, I said this earlier, when you have a test, the top right, to know what that is, go back to your hypothesis. Everything is based on the number 0, so mu d is 0. And we know 13, SD, well, to do SD, we need to do SSX first. In this case would be SSD. It's the same formula, but for the d. Sum of d squared, sum of d entirely squared over n, 295.3. 47.5 squared, and it's a sample of 13. 295.3, 47.5 squared over 13. This number is 1217423. Variance would be the SSD n minus 1, so you take this number and you divide it by 13 minus we divided by 12. And standard deviation would be square root variance, you square root this number. That would be 3.1852. Okay. We put everything in the t-test. D bar is 36538. Mu d is 0. SD is the 1852. And it's the square root of sample 13. So 3.6538 over this square root of 13. This will give you 4.1361. This is the answer of the question. So, we're ready to make a conclusion. Your t-test is 4.1361. If you go to this, this is definitely more than 1782. So this condition is satisfied. You're going to reject H0. Anytime you're rejecting H0, type 1 could be committed. And the risk of committing would be alpha, and that's 5%. So rejecting, accepting, yes, it has increased. So we have enough evidence to show that sales campaign has increased weekly sales for the store. Okay. Now, in the next one, what are the assumptions necessary to perform the test? So when you talk about assumptions in this case, you have to mention the sample of stores must be selected randomly. And if you go back to the question, it's a random set. You don't really have to mention this because they're already mentioned in the question, but if it's not mentioned, you have to assume it. So this one is optional. You can write it or not write it. In this case, it doesn't matter. You also have to assume this is paired sample. So it's a dependent system. Dependent system is also called paired sample. We have one group, the stores, two tests performed, weekly sales for campaign, weekly sales, no campaign. So try and change the wording a little bit I don't want you to have the same identical answer, but this is it. The assumptions usually for this section is random selection, but if it's mentioned, you don't have to repeat it. And the fact that it's paired sample, a dependent system. And the reason is you have one group and two tests. Okay. The last thing is to figure out what the p-value is and interpret the meaning. To do the p-value for t-test, which is this number, you need to do the DTT. D is degrees of freedom, test tail. Degree of freedom, we know sample minus 1, 13 minus 1, 12. Test provided, and it's one tail because we say when it's greater, it's one tail. So once you put this, you go to your t-table, you go to the line degree freedom 12, and you look for the 4. You'll see that in the one I'm using, it's between the last two numbers. Maybe you might see it in your table that it's just greater than the last number. In my table, it would be between the two numbers. It's between 3.9 and 4.3. If I go to the one-tail percentage, it's between 0.001 and 0.005. So, and you go to the one-tail percentage, not the two-tail. So in this case, all you need to say is it's less than 0.001. Or between 0.001 and 0.005, but it doesn't matter, less than 0.001. The way we explain what this is, I'll give you the standard meaning of p-value, and then I'll tell you what you need to change. Assuming H0 is true, the probability of having a sample as extreme as the one in the test is less than 0.001. So the p-value, you always say this. Your only thing that changes is whatever your p-value is. And H0, you don't say H0, you say what H0 is. You say, assuming that the true mean of weekly sales has not increased with the campaign is true, the probability of whatever. So you basically say what H0 is in words, and everything is the same except you change the last thing. This is it for question 3. Question 4, I'm gonna stop this. That would be the end of part 2. I'll stop it, and in the last part we'll do question 4, which requires a lot of work again, but that would be in the next video. Okay? Bye.